This brief video will provide an example of using Bayes' rule to calculate revised probabilities. The example is based on page 87 to 89 in the textbook. The problem is that Thompson Lumber is deciding whether to build a new plant to manufacture a new product. The best estimate is that the market for the product will be favorable with probability 0.5 and unfavorable with probability 0.5. The company is deciding whether to perform a survey to better understand market demand. In order to make this decision, Thompson has solicited the following information. The market research specialists state that in past cases where the market ultimately ended up being favorable, the survey results were positive 70% of the time. That's a correct prediction. Obviously, that means that 30% of the time, survey results predicted the market incorrectly. The market research specialists state that in past cases where the market ended up being unfavorable, survey results were positive 20% of the time. So that means there were positive results and the market was unfavorable, so that's also an incorrect prediction. This means that the unfavorable market was predicted correctly the other 80% of the time. So this is the problem. I'm going to go into an Excel spreadsheet, so you may want to pause and open Excel, and then we'll go through calculating the revised probabilities using Bayes' rule. We'll start this model from scratch here. So across the top, I'm going to put the two states for market demand, and we will use the term prior probabilities for the 0.5 probabilities that are essentially just the best guesses for whether the product is going to have a market that's favorable or unfavorable. In terms of notation, we'll often see this sort of notation as an example, with the P standing for probability, and this notation right here means that the probability of the favorable market is 0.5. I'm just going to repeat these labels here. And then down below, I'm going to enter rows for the positive survey results and negative survey results. In these four cells, we will input the probabilities given that are what we call likelihood probabilities for test results given the state of the market. So the term I will use is likelihoods. Now in this case, when the market ultimately ends up being favorable, the survey results were positive 70% of the time, which means, although it wasn't explicitly stated, that they must be negative 30% of the time. I'm going to calculate this by entering a formula here that subtracts the 0.7 from 1. This will just give me the flexibility to change these likelihood probabilities if we wanted to reuse this model for another decision. In cases where the market ultimately ended up being unfavorable, survey results were positive 20% of the time. So they were negative 80% of the time, but I will enter again a formula 1 minus the cell C4. So now we've got all the information that's given in the problem entered here. In terms of notation, a lot of times what we'll see in the textbook and other sources is these type of probabilities, these likelihoods are conditional probabilities. And as an example of the notation we might see something written like this. And I read this as the probability that results are positive given the market is favorable is 70%. This symbol right here in the middle, if you want to type it on the keyboard, you would hit Shift and hit the key above the Enter key. But when I see this up and down line, I read that given. Now, to calculate the joint probabilities, we would need to multiply the prior probabilities times the likelihoods. So again, I'm going to repeat these labels and repeat the rows for the survey results. So a joint probability is different than a conditional probability. It's the probability that these two events occur together. So if we want to know the probability that the favorable outcome occurs with the positive result, we would need to multiply the likelihood times the prior probability. In terms of notation, this is called the multiplication rule. And it says right here, if we multiply a conditional probability times the prior, we would get the joint probability. Here on the screen I've written the word "and," although sometimes in textbooks you might see an upside down U type of symbol. It's called the set intersection symbol, and if you see that, I always read that as "and." So we need to make this calculation using the multiplication rule 4 times. Fortunately, with Excel, we can really do this, make this calculation one time, and if we're careful, copy it to the other cells. So I want to multiply each of the likelihoods times the prior that's associated with that likelihood. And because I've only got the priors on one row, row 2, I'm going to put a $sign in front of the row 2. What that will do is, when I copy this down and I want to multiply times the likelihood with a negative result, it will leave the prior probability reference on the same row, which is row 2. So once this is done, I can copy this to the right, and we can copy it down. I'm going to move this over one cell. So we've got all 4 joint probabilities. If you go into one of the cells and double click, you notice, for instance, that because we had the $sign, which I call an absolute reference, on the row 2 didn't change when we copied this down, but the reference to the column did change, and that's what we wanted to happen. I'm going to use a feature in Excel called the AutoSum to sum up the joint probabilities, both by row and column. So I'm going to highlight all those probabilities and then highlight one additional row and column, and then go up here on the home menu to AutoSum and click that. And what you see here are the totals, and it should always be the case that all of these joint probabilities sum up to 1. So these are the joint probabilities for each of the market outcomes and each of the results. In other words, the probability that these events and these events are observed at the same time. The other key thing that we see here is over here in this column D, is that now we have the marginal probabilities for the survey results. So the probability that we survey and get a positive result is 0.45. the probability that we survey and get a negative result is 0.55. Now what we need is what's called the posterior probabilities or the revised probabilities. So we're going to repeat these labels one more time. To use this survey for decision-making purposes, what the firm really needs to do is to be able to adjust its decision based on the results that it receives from the survey. So the way it would, the probabilities that can help in that case would be, for instance, the probability of a favorable market given the positive result. This is often called a revised probability because if you notice up here, the prior probability of the favorable outcome was 0.5. Now what we're doing is revising that probability in the presence of new information, which would be the positive survey results. Intuitively, we would probably expect this revised probability to be higher than the original prior, because the positive result we would expect to predict the favorable outcome. But we'll see when we calculate these. So the rule of conditional probability says that to find this revised probability, we need to divide a joint probability by a marginal probability. The marginal probability here, the probability of a positive result, is this event which we could call the conditioning event. This joint probability is the probability of these two events occurring together. One thing to notice is that for this joint probability, when we write the word and or the upside down U symbol, it does not matter which order these two events appear in. The joint probability is the same. However, when we write this up and down bar for conditional probability, it certainly does matter which side of the bar these appear on. This probability here, the likelihood 0.7, is not going to be the same as this revised probability. So we simply make this calculation. So for the first one, this calculation is the joint probability for favorable and positive divided by the marginal probability for positive. I'm going to put a $ in front of the D because these marginals that are in the denominator always appear in column D. That way when I copy this to the right and I want to get the revised probabilities for the unfavorable market state, I won't have to update the formula. So that's 77%. And I'll copy it down into the right. And just as a final check, I'm going to use the auto sum to total these rows, and they should both sum to 1. Because given that the positive result occurs, only one of these two events is going to occur next, favorable or unfavorable. So we've revised the probabilities now. The prior probability of a favorable market is 0.5, but in the presence of a positive survey result, the probability increases to 77.77%. In the presence of a negative survey result, the probability of a favorable market decreases to 27%. Some of you in the last discussion forum were able to use this information and some information on the payoffs to calculate expected values, and those could help the firm make the decision on whether or not to go forward with this plant. Hopefully this example of Bayes' rule could be applied to some of the other problems as a good review of this topic.